All right, in this video, we're going to talk about percent error. And percent error is something that you can use to compare your work to known accepted values to see how good your answers actually are. And you want to obviously have a low percent error because that means you did very good work. Maybe you were meticulous in the lab, you made sure that you were looking very closely at the measurements, you were reading to the correct number of significant figures, or at least estimating that last digit as best you could. Now, in New York State, we use the chemistry reference tables. The third one down is on the back table on table T is our formula, and we can see it there, and I'll have it up on the board, but we have measured minus accepted divided by accepted times 100. So let's say you went and you did some work and you were calculating the density, and let's say the density you came out with was 3.3 grams per centimeters cubed, or maybe it was grams per milliliters, depending on what you were using, either solids or liquids. And let's say the accepted value was 3.0 grams per centimeters cubed. We then want to subtract that, and then we're going to divide that by the accepted again, 3.0 times, grams per centimeters cubed. Don't forget the 100, because if you leave off the 100, you're going to not get the right answer that you actually need. So obviously we could redo the math, or we can just plug it all in our calculators. But if we're going to do it step by step, on the top it's really an absolute value, and that's just going to determine whether you're higher than the number or lower than the number when you get your answer. But your error obviously is going to be the same as a percent. It just could be lower or higher. If you get a negative number, that means you were lower. A positive number meant you were higher. So for example, my math here really is 0.3 divided by 3.0 times 100. But if I instead came out with a different number, let's say I was 2.7, if I use 2.7 minus 3, then I would have been at negative 0.3 over 3 times 100. So my answer is going to be a negative value. That just means I am under as compared to being over. But in reality, it just means I'm the same distance apart from where my error was. So when we take our calculators, we plug it in 0.3 divided by 3 times 100, and that's going to give us, in this case, a 10% error. Now, 10% isn't horrible, but it's also not great. Anytime you're doing labs, if you can get anywhere, obviously a 0-point error would be amazing. Anything up to 5% error is really good. 5% to 10%, not too bad. Anything beyond 10%, especially if you're at 15 or 20% error or greater, that means you probably messed something up or drastically did some error. Maybe you really, recorded possibly a volume wrong. If you had to use length times width times height and did three measurements that you had to measure, that's a lot of room for error. Obviously, if you're using a graduated cylinder with milliliters, make sure you're recording and estimating those numbers correctly according to the striations on the graduated cylinder. So again, with percent error, it's measured. The measured value is the value that you physically measured and you physically calculated in the lab experiment, where your accepted is what's given. So for example, in the New York State Chemistry reference tables, that would be table S. We could look up density of certain elements on table S, and then we could compare them to the density that you got in the lab. So hopefully you found some value. Again, measured minus accepted divided by accepted times 100 for percent error. Thanks.